Good morning, scientists. So today, your job is number one, you need to get that remediation done. I have some students that still haven't done the remediation. You have till today at midnight. If it's not done today, forget it, you lost your opportunity. I gave you an opportunity to go ahead, get that done. Many of you who needed to have already got it done. Good job, excellent. However, I've got a few students that didn't do so well on the last test. I really need you to do the remediation. I'm doing you a favor. I want to make sure you understand this stuff. You've got another way, another method of showing me what you know. So take advantage of that. Don't squander it. All right. So again, due by midnight tonight. All right. So today's lesson is all about gravity. So there's a short video about gravity. She does a fantastic job using some animations and explaining gravity. I'm going to try to do something tomorrow in the trampoline using that as a model to show gravity, and also go over the answers to the remediation tomorrow. That's why today's the last day you could get that done. So if you've got a very large object, it's going to have more gravity because it has more mass. Smaller objects are going to have a lot less mass, so they have less gravity. So if we had two planets, one large one, one small one, this smaller one's gonna get pulled towards or pulled into orbit around the larger one. If it's not moving fast enough, it'll just crash into it. So, for example, the Earth, we have little meteoroids that end up, some of them get trapped in Earth's orbit and eventually enter the atmosphere and burn up. That's what happens to most of them. They fall to Earth as dust. So that happens every day. Other smaller ones, they might be large enough where they go through the atmosphere, they burn up, and there's still something left of them, and they crash into our planet. So they're so small that they get pulled into Earth's gravity. Earth doesn't really get pulled towards them, really has very little effect on Earth because it has so much mass. Then again, the Earth's mass compared to the sun the Earth has very little mass compared to the sun. So that's why the Earth is in orbit around the sun. I know it's a soccer ball, it's not the Earth, but this will have to do. So that's the main thing about gravity. Mass affects the amount of gravity. The second thing that affects gravity is the distance between the two objects. So if I had two objects that are very far apart, the force of gravity, the gravitational attraction between the two will be much less. The closer they are, the more the gravitational attraction. So you, me, this camera, these little toys here, they all will fall because they're attracted towards the center of the Earth. So all objects are attracted towards the center of the mass. So if you have a large planet, everything's pulled down towards the center of that object. So whether you're here, you're pulled down towards the center. Whether you're down here, you're being pulled towards the center. So when we're talking about up and down, wherever the center of the mass is, that's down, and the opposite direction, that's going to be up. So of course, up for, let's say us over here in Cooper City, is going to be different than, let's say, up for somebody down in Australia. So it's going to be a different direction. So when you say up or down, that's relative to the center of the Earth. So not necessarily the best way to explain things if, let's say, you're traveling to the moon or out in space. Up and down doesn't really have much meaning. Once you're out in space and there's no gravity, there's really no up or down then. So a little different meaning. All right, that's it. So today you got the video, you got the quiz about gravity, and if you didn't do the remediation, get that done today. It needs to be done. All right, so if it's not done by the end of the day today, too bad. All right, so make sure that's done. All right, so long, stay curious.